Okay, so let's put it all together. Let's graph this cosine graph. And then let's do multiple periods with it too to see that we can construct multiple periods. Okay, so I went ahead and labeled all my transformations. That negative out front is an x-axis reflection. The amplitude is the absolute value of -4, which is 4. That's how much it'll go up from the midline. And then I've got a shift pi force to the left because it's plus. So it must have been x minus a minus pi force. And then we have a vertical shift up 3. Okay, so first thing I want to do is start identifying all these transformations. Okay, so I'm going to go ahead and erase and then let's begin. All right, so if you recall, I said when we had, say, a horizontal translation or a vertical translation, where did we begin? Well, I said with this one here of up 3. Okay. All right, here's our xy plane. And remember, we can look at x as distance, or we can view it as time, depending on the situation we're modeling. All right, so if we begin with a vertical shift up 3, let's go ahead and put that in. Well, that means instead of our, say, x-axis being the middle line, we're going to shift it up by 3. All right, again, and let's go ahead and label that midline. That's y equal to 3. Okay, next. Well, we've got a shift here, pi force to the left. Okay, so I'm just going to kind of... Now, there's a little bit of art to when we say move this pi force left. Well, I know it's going to be on the negative side here. Negative pi force. But I'm not going to give it a location just yet. And you'll see why in a minute. Okay, so negative pi force, I know somewhere's in negative territory, and that's where I'm going to begin. All right. Amplitude. Well, that's 4. Absolute value of -4 is 4. How about period? Time it takes to do one cycle. 2 pi over the absolute value of b. Well, the absolute b here is just 1. Would be here in front of the x after the cosine. But there's nothing there, so we assume it's 1. So my period equals 2 pi. 2 pi over 1 is 2 pi. Okay. All right, so we know we begin at negative pi force, and we know our period is 2 pi. Well, let's figure out where it ends. So that's negative pi force plus 2 pi. Okay, negative pi force plus 2 pi, again multiply by 4 over 4. So that would be negative pi force plus 8 pi force. So that's going to end at 7 pi force. Okay, but now more importantly, I have to take my period and do what? Well, divide it in 4 parts. So let's go ahead and do that. 2 pi divided by 4. Well, that gives me pi halves. So that's how much I'm going to add to my starting location each time. Okay, so negative pi fourths is again where I start, plus pi halves. And the reason I didn't actually put that location in yet is because I want to make sure that, say, once I add my first location to it, I've correctly put it here on the other side of the y-axis. Okay, so negative pi fourths plus 2 pi fourths, which is the same as pi halves, would be pi fourths. Okay, so I can now safely put in both because I know if I'm at negative pi fourths and my next location is pi fourths, notice the y-axis isn't one of my locations, so I have to be careful that I don't mistake the y-axis there for one of my locations. Okay, let me erase. And I'm just going to keep here the idea that it ends at 7 pi fourths because I just want to do one period's worth first, and then we'll do another period's worth. Okay. Okay, and then remember when I did my period here divided in 4 parts, the amount I'm adding each time to it is pi halves. Okay, so let's go now from pi fourths here, and let's add to it again now. Pi fourths plus pi halves, again times 2 over 2. So that's 2 pi fourths. Pi fourths plus 2 pi fourths is 3 pi fourths. Okay. And these are all equal lengths here. 3 pi fourths. And notice I'm putting along my midline, not my x-axis here. Okay. All right, let's add to it again. Plus another pi halves, which we know is 2 pi fourths. I'm just going to leave it as 2 pi fourths, even though those are the same thing. And that's 5 pi fourths. And then if I added another 2 pi fourths to it, I'd be at 7 pi fourths. Okay. So I knew it ended at 7 pi fourths. That I just added on my period length to my starting point to see where it ends. And that's going to be helpful as I construct these. Okay, so let's go ahead and make the graph. Let me erase here. Okay, and then of course I'd evaluate my points. F of negative pi fourths, negative 4 cosine of negative pi fourths plus pi fourths plus 3. Well, that's the cosine of 0. Negative pi fourths plus pi fourths is 0, multiplied by negative 4 and then plus 3. Well, then I think cosine is x, and when I'm at 0 on the unit circle, my x value there is 1. Negative 4 times 1 is negative 4, plus 3 equals negative 1. And I'll just go ahead and dot it in here. All right, let's do another value. How about positive pi fourths here? Put in positive pi fourths. What's pi fourths plus pi fourths? Well, that would be 2 pi fourths or else pi halves. So the cosine of pi fourths plus pi fourths is 2 pi fourths, which reduces to pi halves. All right, the cosine of pi halves. Well, I'm up at 90, so I know my x value there is 0 on the unit circle. Multiplied by negative 4 is 0, plus 3 is 3. Okay, so then here are the plots, and notice I accidentally had plotted negative 1 on positive 1 there when I made that, and I've moved that down here to negative 1 to where it should have been. Okay, so then I plotted all my points after evaluating, and it takes this shape, and that's what it looks like after one period. Notice, because it's negative here, instead of it starting, say, at the positive amplitude, it starts at the negative amplitude, which is down here, 4 from the midline, down at negative 1, at negative pi fourths. And notice also that the y-axis is not a location along the way. Okay, so I'm just going to cross that off. It goes from negative pi fourths to positive pi fourths, but notice the y-axis isn't one of our, say, cardinal locations along the way. Okay, and remember, I took whatever my starting point was, negative pi fourths, I added the period length to it, and then I found the ending location, 7 pi fourths. And then, of course, I took my period, divided it in 4 parts, and I added whatever that amount was, which happened to be pi halves, to my starting point, and then to every location after that. So negative pi fourths plus pi halves is pi fourths. Pi fourths plus pi halves is 3 pi fourths, and so on, until I will have completed the graph here. Okay, now let's do one more period of this. Let me erase. Just to show that we could, say, add another period onto it, which we want to, say, construct maybe multiple periods of these. All right, anybody recall what our period was on this one? Well, we can always look and find it out again. Period. 2 pi over b. b is just 1, so 2 pi. Okay, so if I end here at 7 pi fourths, well, then I'm going to take 7 pi fourths, and I'm going to add 2 pi to it. Again, my period. To construct a second period of this, okay? Okay, so 7 pi fourths, I'm going to have to multiply this by 4 over 4. So that'll be 7 pi fourths plus 8 pi fourths. And that would equal 15 pi fourths. And I'm just going to go ahead and dot this down in here about another period's length down. 15 pi fourths, which I know it should end after one more period. Okay, so let me erase. So what did I do there? Well, I added the period length to wherever my last period ended, which was 7 pi fourths, and I added 2 pi to it. Okay, and that got me to 15 pi fourths, so I know that that's where it's going to end. But to get there, I'm just going to take again my period and divide it into how many parts? You got it, 4 parts. Okay, so that would be period divided by 4 parts. 2 pi divided in 4 pi halves. So I'm going to add whatever that amount is to 7 pi fourths, because again, now this is where I'm starting my new period. So 7 pi fourths. And again, look, it's going to be more helpful just to keep it in this original form because it already has fourths. 7 pi fourths plus 2 pi fourths, 9 pi fourths. Okay, divide it equally in half, and then in half again equally. Okay, so I know now my next location, 9 pi fourths. And maybe I see the trend. Pi, 3, 5, 7, 9. This should be 11 pi fourths. 13 pi fourths. And finally 15 pi fourths where I finish, which is what I concluded was my ending location. Then, well, I know it's going to obey the same pattern, so I can probably do this without evaluating if I feel comfortable, but I can always evaluate those points if I need to. And finally back here to -1, my last location, and I want to then draw the second period's worth. Keeping in mind it's got that sinusoidal shape. The tops, the maximums are called peaks, and these areas are called troughs down here, troughs. And peaks. And if you were, say, just looking at this graph and you wanted to measure a period length without knowing it, you could do peak to peak to measure the trough length. I'm sorry, the period length here. This is, say, if I needed to measure the period. Or trough to trough. So from here to here. In other words, 15 pi fourths minus 7 pi fourths leaves me with 8 pi fourths, which is 2 pi. So I can always say calculate a period if I was looking at a graph by measuring the distance between their troughs or the distance between their peaks. And that's the length of one period. Okay, and notice here on this graph we constructed 2 periods worth of our function. G of x equals -4 cosine of the quantity x plus pi fourths plus 3. So hopefully this puts it all together for you, and also this is problem number 47 in your book. Okay, thank you.